as Alex mentioned in his email to the community, Daniel has invested quite some time in doing research around code review and applying those conclusions to improve open source community projects. He's also brought such experience into corporations so they can improve their code review process. I also thought it was fascinating that Daniel earned his PhD in free software engineering, specifically focusing on the analysis of buggy developers' activity patterns in the Mozilla community. So with that, please welcome Daniel.
Well, thank you, Amanda. That has been a really great introduction. So thank you. So thank you for having me here. So this is the first time me joining this group. So it's an absolutely pleasure for me to be around, and well, I do my best to to share my thoughts on code review and the analysis over the years. So this is a link coffee. So this is going to be an open discussion on code review, and then I bring in like 2 or 3 use cases for illustrations, and then we can learn what this is. So well, you already know about me, so that's my LinkedIn or email, just in case you would like to drop me an email or add me to this. So happy to. As Amanda said, so I've been before this journey into a company doing empirical software engineering for a few years, and then I finished my PhD in 2012. So just to mention, and I think this is quite interesting probably to start with, is that code review is a practice by default that exists in open source nowadays, right? But this was not that much of a practice like maybe 20 years ago. In the case of specifically the Mozilla community, when around the years I was doing the PhD somewhere between 2007 2012, only just a few of the projects, the most important ones, Thunderbird, Mozilla, the Firefox, sorry, the browser and so on, they were enforcing code review practices, but this was not like general specifically there. And this was probably something happening as well in other communities, where if you had this role of committer, so people trusted you in somehow, then code review was perhaps not that much of an interest. So that depends on the community. They embraced code review earlier. They embraced perhaps code review a bit later. But in any case, let's start with a definition of code review. This is quite interesting. This is coming from Wikipedia. This is one of the snippets from Google, of course, when you are looking for code review definitions. They focus a lot on software quality, right? As a way to kind of keep track and updating all the quality in the software. They mention others if you go to the Wikipedia page, but they specifically say this at the very beginning: software quality. This is quite, I would say, highlighting of, and I would say even biased, of who wrote this at some point, because there are other discussions, and that's something that we can discuss later. But just to start with, let's go with this. And just to be sure, when I wrote the abstract, when Amanda asked me, hey, do you mind, sharing a title, saying an abstract? So one of the words I was saying was the word essential in software development activities, but this is essential specifically for open source. And this is because this is a zero trust environment. We are talking about people that are collaborating with others without initially consensus, but there is no previous way. I trust you, I know you, so I don't know how you work, right? So this is about open source. It's about having geographically distributed people working together to produce code. So code review is one of those processes enforced by tooling typically that need to happen, because if not, things would be broken once and again. So open source is the place, where everything is open by default, even whatever you're producing, code, discussions, most of the discussions, we can say, comments, communications, etc., etc. But then when we enter into producing valuable assets for the project, then we enter into this zero trust environment. And this is not only applied to open source, this is applied perhaps for documentation, guidelines, and many other assets that the community may have. So this is quite important for the discussion of code review, specifically in the case of open source. And this is an example of the open infra. Open infra is the foundation hosting OpenStack. So I assume that you are more or less aware of this free open source software solution for to build clouds. But really quick is, you have your developer environment, so then you decide to work on a specific piece of software. So you clone the software from some place, and then you start digging with things, and then you have to run unit tests, right? And then, of course, then once you are happy with this, you send this change request. Depending on the platform you're using, GitHub, GitLab, in this case, in OpenInfra, they are using Gerrit. They may have slightly different processes, slightly different namings here. But then there is a Gerrit process, code review process, as you can see here. And then there is, again, a unit testing or automated testing process. And then, again, once this is kind of approved by everyone, not only the testing, but a human being or two human beings in the case of OpenInfra, so they go through a code review process by two people at least, then they go into another automated testing process. So what I'm highlighting here is that code review by itself is probably not enough. And then in the case of open source, there is a big amount of unit testing around. So it's, again, zero trust environment. We really need to be sure that you are not breaking whatever you are proposing as a change. Then the, OpenInfra, now going to this specific example, is quite interesting because code review might be a good way to cheat on metrics. And OpenInfra had this problem years ago, that if you were producing code reviews, then you are having and growing, as an individual. So then at some point you could be elected to be a code reviewer. A code reviewer is the person that has basically the rights to say +2 or -2. That means that your code will be basically merged into the main branch. So basically, is the person with power, right, to do certain things. So what happened at the beginning with all of these code review activities is basically that people were saying +1, +1, +1 after someone else said +2. So then what happens is that you are sure that whatever you are reviewing is right because someone, a co-reviewer before, said +2. So, once you have this kind of metrics to do certain things, and code review is part of this, of course, then you can cheat on the metrics. So that's something to consider and to have in mind. But anyway, what I wanted to highlight here is code review by itself is not enough. So we need to have all of these automated testing around the process. And then perhaps as kind of a reflection is that, well, code review is the thing is there because it's needed, because we are working in a distributed community. So it makes sense in the case of open source, because by design we need to work with others in a certain way. So code review is this way that people have. And by the way, like code review, so we are not discussing about these heavy code review processes that used to be in corporations years and years ago. It's a light review, and by light review I mean specific batch sizes of the commit, perhaps up to 50, 100 lines. So there are certain good practices on how to have first a good pull request, a good change request, and then a good, at the same time, change code review process. So it's a discussion and good practices coming from the submitter, but from the code reviewer as well. Okay, it's about getting people to understand each other. Now entering into some examples. So this is the same community, but you can see here is basically on the x-axis from left to right is the number of patches that they have for patch series. The same community or the same project is in the orbit of the Linux kernel. So then you know what more or less the environment we are discussing here. The terminology that they are using is basically for each change request, they can change many things, right? So then each of those are patches. It happens that they are using mailing lists for the whole code review process. So if you want to send a new code review process, you send an email, right? If you want a second patch to be part of this, you send another email answering this, and then another email, another email, another email. So basically, you can see here at the very end of the table. When if you don't see, I will let you know. This says 64. So it means that there is a thread at the same community, at least one thread that has 64 patches. So how is the code review going? So basically, people has to answer to each of the emails, say, well, I would like this change to be made, like right? And then they are using certain flags to say, okay, this is act by me, this is reviewed by me, this is tested by this other person. So there is kind of, this is almost fully automated, let's say, from that perspective, if you are a developer, but they are using mailing list. all of this process. Okay, so what it happens here is that basically the more right you are, the more complexity we are talking, because the bigger the size, the more noise that in the community there is, right? And then it means that at the same time that more time is needed. So when we were discussing with the same community community leader, Lars talked to us and said, hey, we know that we have a problem. There is a decaying process in the code review. So what's going on here? So they needed data to raise what was happening in the community. So then the problem was they had certain perceptions. Maybe it's because of language barriers. Maybe it's because we are creating more and more complex code. Maybe it's because there is a lot of noise in the community. You can see that there are many emails sent to the mailing list where normal communications happen as well. So then what was the problem? So part of the problem at the end, or what we discovered through this code review analysis, is that yes, the friction happens when people have to talk to people, and then at the end of the journey, what it happened is that for one unit of one patch basically of the patch series took 1 unit of time. So there was kind of a linear increase, but there was a moment in time, I think like 15 or 20 after this size, that the time to review everything started to become exponential. So basically, okay, a recommendation was basically to split, patch series into something smaller, and then we come back to this discussion about having good practices from the submitter perspective and the code reviewer perspective. So this is an example of this process in the mailing list. This is a thread for a given patch series where you have in this case, a patch that is based on 3 specific patches. So there is a patch series of 3. And then you can see that for some of them at the beginning, there are some discussions happening. So this is how a code review happened in code review in the same community. I'll go quicker because we are now 20 minutes after the hour. So this is an example for the Linux kernel where they are, dealing a bit better with all of this. In terms of the size of the numbers that we are talking here from a quantitative approach, is that we have 1 million messages that were part of this whole process. Like a third of them were around discussing on code review. And then really quick on OpenStack, which is the second example here, is you can see this increase in the time to merge. Basically, this is the time to take inherit a code proposal and then merge this. So there is in Q4, Q1, Q2, and Q3 in 2014, so this is all data, there was an increase in the time to merge. So something was happening again, right? So what is going on here? Then we discovered a couple of things. On the left, you can see the evolution of the time waiting for a reviewer action. So there are 2 people involved here, right? Submitter, reviewer. So then there is an increase in the time, so probably the workload adequacy of the code reviewers was not enough. So then they needed to bring more to bring more people as a code reviewer. And on the right, what you can see is that there was perhaps a similar increase for submitters. In the case, they discovered that, well, newcomers were joining, so they needed some extra training and so on. So again, it's what are the pain points of my code development process or my software production at scale. So then you can enter into these details if you have the data, right? OpenStack, totally different thing. So then they were using Gerrit, it's way more structured information. So then you can see this is an example of myself talking to some OpenStack people here and there. And the last one is inner source. So inner source, in the case you are not aware of this, is about bringing good practices from open source. The problem they have, and this is why we have this beautiful silos image here, is that you have large corporations producing once and again similar pieces of software. Basically, information is siloed in somehow, right? So then inner source is about enabling and breaking down those silos. It happens that now we are at the stage where we have geographically distributed people that need to collaborate with each other. So then that's open source. So then it's, again, this is the other space where I've seen that code review is kind of essential, if you let me use this word for code review. At the end of the journey, and then I'm almost done here, is these are my personal thoughts perhaps. So you have this line here that is telling you, well, CI/CD DevOps is about applying engineering practices once we have the code in the main branch, right? Inner source, and perhaps the way of working on open source, is about bringing software engineering practices to the left part of the software production chain. So then this is code review. It's about bringing those good practices. Is this the right approach in internally in companies? Your experience? So that's something that we'll discuss now. And just really final thoughts. I promise this is the last slide. When I was invited to an academic event, we were 3 or 4 coming from industry. I had this both hats, right? In academia, all academics were saying, well, code review is essential for quality assurance. And then the 4 people that we were coming for industry, we were saying, well, this is quite important for knowledge sharing, for mentoring newcomers, and even for company resilience. But, well, for the quality assurance, we were not that convinced about that. So that's probably thoughts for now to start the coffee discussion. This is all. So this is me. Thank you.